Hello everyone, welcome to this class. We're now in chapter 7 of our book 1. Now I want to show how to represent the algebraic equation we did in our previous chapter in chapter 6 and chapter 4 as a graph, and also how to solve equations from it. First example we are going to look at is, I'm going to solve from this book for convenience sake so that we'll save to be more clear and if it's let's go to example 1. Example 1, we have something like this. I believe this is a mistake. I think what they want to say here is y is, but from the graph they are drawing, you can see that the graph is the equation of y equal to 3 minus 2x. So that's what you're going to write here, 3 minus 2x. Now you're seeing something like this, 3 minus 2x. I think here is supposed to be y. Here is 3 minus 2x. Now you are seeing minus 2 and plus 4. Now look at the range. I think what they are trying to do is check from the range of minus 2 to plus 4. So let me put it, range of minus 2 to plus 4. I might not necessarily need to put the plus. I think this is what the question is all about. Now we are being told calculate the value that corresponds to the whole number value of when x is minus 2. So indirectly, let me tell you what they told us to do here. Now we have been given the range of minus 2 to plus 4. First thing we are going to do is to draw a table. This is x and y. So we already know that x is minus 2 to plus 4. So what does it mean? Minus 2 is minus 2. If you add 1, you have minus 1. If you add 1, you have 0. Add 1, you have plus 1. Add 1, plus 2. Add 1, plus 3. Add 1, plus 4. And that's the range we want. So we already know for x. Now we have to start looking for y. So the first thing we are going to do, we already know that y is 3 minus 2x, right? So for the first one, we have it that y is 3 minus 2 times minus 2. We should give you that y is 3 minus 2 times minus 2 will give you plus, so 3 plus 4. Minus 2 times minus 6 plus 4, I'm sorry to say. So 3 plus 4, so y will give you what? 7. That's what the 7 you are getting here. So let me jump step and go to 0. They just use the same step to solve for this, and everything. So let me go to 0. This is for x equal to minus 2. Let's go for x equal to 0, so we can solve everything inside this small sheet. So you have y is 3 minus 2 times 0, which is equal to y is 3 minus 0, which is same as 3. So when x is 0, y is 3. So let's jump to when x is 4 and plus 2. X is 2. We have y is equal to 3 minus 2 times 2, which is the same as 3 minus 4, which is the same as minus 1. So that's what we have here. Let's go to when x is 3. X is 3. We have y is 3 minus 3 times 3. So which is 3 minus 6, which should give you what? Minus 3. And that's what we have here. Let's go to when x is 4. So y is equal to 3 minus 3 times, what am I doing? This is 2, I'm sorry. This is 2 times 3, which is minus 6, not 3 times 3. So let's go back. So this is also 2 times 4. So we should give you 3 minus 2 times 4 is 8. 8, which is what? Minus 5. And that's what you have. So by so doing, we've solved the first problem, which is the range. You understand? So the next thing we are going to do is to plot a graph. In this case, I'm going to use the graph they've already drawn. You understand? So plot a graph, but I'm going to show you how they were able to do plot the graph. First thing first, you've already gotten your table. This table is very important for plotting graphs. So you are going to have a graph that the x-axis must have everything in this x row, while the y-axis must have everything in this y row. It's not a must. Like you can see that here stopped at minus 8, and here stopped at plus 8. So the most important thing is that this y stopped at minus 5. So minus 5 is inside here, and started at plus 7. Plus 7 is here. So don't put something that you can't find the value in the graph. For the case of x, it stopped at plus 4, which is what we have. Started at minus 2, which is what we have. So that's sorted out. So let's start plotting. The first thing you're going to do is, when x is minus 2, what is y? When x is minus 2, what is y? So let me zoom this graph a little bit more so we can see what we are doing. So it's now zoomed. When x is minus 2, where is minus? This is minus 2. Y is plus 7. So you go to, sorry, I'm mistaking it. When x is minus 2, this is x. I went to go and look at the y. This is x. This is minus 2. Y is plus 7. So you go to 7. Look at it. Here is 6. Here is 8, right? Now look at it. The distance, the square. Because this is 6. You have 1. I don't know if this is visible. Let me check. You have this first box here is 1. Oh, this one is 2. Let me zoom this further. So you can see this is 1, this is 2, this is 3, this is 4, and that's 5. So you can see that 2 to 8 minus, let's do a little math here. Because we're trying to get the scale of each of the line there. 8 minus 6 is 2. But we have 5 division lines, so 2 divided by 5, we are getting 0.4, right? So meaning each of the square is 0.4. 0.4 times 5 is 2, which will give you 8. So the middle of this 6, let me just make it more easy. The middle of this 6 and 8 will give us 7. So that's like when you count the first one, 1, 2, in between, this in between, like that's 7. So that's what you have here. When x is minus 2, y is 7, you now put a dash there and leave it. Go to the next one. When x is minus 1, y is 5. This is minus 1. 5 is the middle of 4 and 6. That's the middle. Make sure that it coincides with where the line coming out from 1 meets the line coming out from the x-axis, meet the line coming out from the y-axis. We call them the intersection point. Okay, when x is 0, y is plus 3. This is x being 0. So 3 is the middle of 2 and 4. So that's 3. When x is 1, y is also 1. This is 1. 1 is the intersection of 0 and, sorry, the middle of 0 and 2. And that is it. When x is 2, y is minus 1. This is x being 2. Y is minus 1. The minus 1 is still the middle of 0 and 2, which is the middle here. When you bring it here, you see it. When x is 3, y is minus. This is x being 3, y is minus 3. Minus 3 is the middle of 2 and 4. This is the middle here. There is the intersection point. When x is now 4, y is minus 5. This is x being 4. You come down to the middle of 4 and 6. So after you finish doing that, you now use a straight rule. This is the dash here. You now place it. Make sure that you get the middle of all the intersection points. And then you now strike it. Once you strike it, this is what you get. You've already gotten your graph of y equal to 3 minus 2x in this range. So the next thing you are going to do now is that you can now use it to answer some questions. First question says, what is value of question A? Let me zoom out. Or will I say, let me write it out. Question A says that we should find, so this is question A, we should find y at if x is 1.4. Simply go to the graph, look for 1.4. This is 1. To get 1.4, remember that I said that each of this square is 0.4. So this will be 1.4, this first square here. So this is 1.4. So you now look for the value of y. So for you to get it, just look for the point where the x-axis you've got to meet this line, this new line that you have. That line is the graph. It's a straight line graph. Understand? When you have the power of x and y to be 1, the line usually produces a straight line graph. But in the next class, we show when the power of x is square. You see where you have quadratic graph that looks parabolic in nature. So where you have that here is 1.4. Knowing that 1 to 2 Or like, let me say, okay, this is different. The 0.4 we did is for the y-axis. For the x-axis, let's say something like, look at it, we have that. We have 2 minus 1 is 1. Here we have 5 squares, 1, 2, 3, 4, 5. So if you divide by 5, you get 0.2, meaning that each of these box in the x-axis is 0.2, while in the y-axis we solved it earlier is 0.4. So this is 1.2, this is 1.4, this is 1.6, this is 1.8, and this is 2. So we are being asked to look for y at a point where x is 1.4. So simply do 1.1 and 2 and 1.4. So what is y? Move up. Where does it meet the y-axis? This is almost 0 because this is 1.4 and the line almost crossed at that point. So let's see, this is almost 0. So if you look at the answer, you're going to get that. So if you look at the answer, you're going to get that y is at 1.4. Y is what? 0 at 1.4. But let's say we are looking for at x at minus 1.4. At minus 1.4. So we now go to the other side. This is minus 1. So this is minus 1.2. This is minus 1.4. See, they even have the line here. You now follow the line. And when you reach here, you now sketch it and come here. Remember what I said earlier, that in y-axis, each of these box is 4. So this is 4.4, 4.8 plus 0.4 will give you 5.2 plus 0.4 will give you 5.6. And now it is between this 5.6 to 6. So you can take the middle. It's in the middle. So we can call it 0.2 and add it. It will be what? 5.8. So at this point when x is minus 2 and minus 1.4, y is 5.8. I know this thing might look rough. So if you look at the answer, let's look for the answer. At x minus 1.4, y is what? 5.8, which is what we got. The next thing you are being told to look for, if y is minus 4, what is x? So let's look for the point where y is minus 4. This is y being minus 4. They even have the line here. So you trace it to where it hits the line that we drew from the graph. If you trace it, you are going to hit somewhere here. Remember I said in the x-axis, each of these points is 0.2. So here with 3.2, here is 3.4, because we're going by. So now this is at the middle of 3.4 and 3.6. So we can call it 3.5, which is what they got here, 3.5. So at the point where y is minus 4. So let me zoom out so we can now see the questions and the whole chapter. So we can now see that these are the question A, when x is minus 1.4. This question is really messed up. So I'm already showing you the real thing they were asking, which you can confirm from the answers they are getting. So at the point where they say 3 minus 2 is equal to minus 4, what they mean is at the point where y is equal to minus 4, which we've solved. All you need to do whenever you're solving for this kind of thing is, after you've gotten your graph, so long as your graph is correct, anything that I've been told to look for, we have been told to look for y when x is something, just go to the point where x is that and draw a straight line to meet this line, whatever the line, wherever it meets the line, you trace it and look for what the value of y at that point. That's your answer. On the other hand, if you're being given y to look for x, just look for the value of y you are being given for, trace where it meets this line, wherever it meets the line, trace it back to the x-axis to get your corresponding value of x. So let's solve an equation. And my next exercise, this exercise I'm going to start it from the beginning to solve it. For those of us that don't understand this, I believe that one you will understand it clearly. So let's go to exercise 7a number 1. Table 7.2 gives corresponding values of x and y for the equation of y equal to 3x minus 2. So this is the table. This is what they give us in table. They give us minus 1, they give us 2, and they give us 5. But knowing that I'm going to draw a graph, I know these values might not be enough. So I added 0. I added it to be minus 1, 0. Because if you add 1 is 0, plus 1, 1. This is 1. It looks like 2. Plus 1, 2. Plus 1, 3. Plus 1, 4. And plus 1, 5. So I'm going to solve for this. But let's go this. Let me complete this table first. The graph we are looking for is y equal to 3x minus 2. So when x is 0, let's go, x equal to 0, I'm going to have y equal to 3 times 0 minus 2, which is the same as 0 minus 2, which is what? Minus 2. So I'm going to put minus 2 here. When x is y, okay, x is 1, I'm going to have y equals to 3 times 1 minus 2, which is the same as 3 minus 2, which is the same as 1. I'm going to put 1 here. So when x is 3, I'm going to have y equals to 3 times 3 minus 2, which is the same as 9 minus 2, which is the same as 7. I'm going to put 7 here. So when x is 4, I'm going to have y equals to 3 times 4 minus 2, which is the same as 12 minus 2, which is the same as what? 11. I'm going to put 11 here. So this is my complete table. The second question says, choose a suitable scale and draw the Cartesian graph of y equals to 3x minus 2. So let's do that in the next page where there is graph. So this is the first question. It says, choose a suitable scale and plot this graph of y is equal to 3x minus 2. So the scale I choose in this case is, I choose this, my graph is actually different. That's why I say we're going to start from scratch and do it by ourselves, you understand. The graph that they are using in the book, look at my graph. You have to note my graph is 1, 2, 3, 4. It has this, the division is up to 10, but the one they use in the textbook that we did in previous class is 5. So I can say I'm using the graph of the scale I choose. I can say I'm using the scale of 1 cm to 1 unit for the y-axis. And you notice what I did here. First, I first look at my y. I notice that my y starts from -5 to 13. So I choose a scale that will be contained in this book. Let's assume we choose a scale of, well, I'm choosing, let me call this 1 cm. I'm using 1 cm for 2 units of y-axis. Let's assume I'm using a scale of this 1 cm for 1 unit. You notice when I start from -5 here, let's say you start from, by the time you check, notice it will pass, it will not be contained. Even the one I knew, if you notice, I'm going by 2 unit. This is -6, not -5, -4, -2, -0. Sorry, 0 does not have minus. And here is plus, +2, +4, +6, +8, +10, +12, +14. Now this 14 means it's above the 13 we are looking for, so it's okay. It means that 13 will be somewhere inside here. So coming to the y-axis, it starts from -1 to 5. So I already know that -1, let's assume I'm using one unit, one box for my 1 unit of x-axis. So here will be my -1. Here is already my 0. I can now do 1, 2, 3, 4, 5. You understand? You observe that I shifted this line this side because the negative side does not have much value, but the positive side is have the value up to 5. So I consider the positive side more. So the first thing now, we are going to start picking up the coordinates. When x is -1, y is 5. So this is -1, right? So this is 2, right? And this is 4. So the first question you ask yourself, this one box here, what's the value? All you need to do is 10. This is it. I have 10 boxes in total. So I can just say for the y-axis, I'll just do 10. I will say, okay, this is 2. Because I'm taking 2 for 10. 2 divided by 10. So each box is 0.2. Right? So by the time I count it, but I already know that this is 5, this is 4, this is 6. The middle of this 6 and 4 is 5, if you want to go by that way. But then this is important to note, so that when we, but for the x, let me do for the x-axis. This is 1. The box is here at 10. You can just say 1 over 10. So we already know that for the x-axis, each box is 0.1. So if we go by 0.2, this is 4.4. This is 4.2, 4.4, 4.6, 4.8, 4.5. So this is my 5. And this is my -1. So where did the 2 meet? I'll draw an asterisk here. The next thing is when x is 0, y is -2. This is x being 0, this is y being -2. I'll draw an asterisk here. Or should I use another color so it will be more visible for us. Let me use another color. So this is blue. This is, so the next thing is when x is 1, y is also 1. This is where x mean 1. So what we want be, let's count for, this is y, but y is positive, so the 1 is positive. So we'll go 1.2, 1.4, 1.6, 1.8. Sorry, 0.2, 0.4, 0.6, 0.8. This is now 1 somewhere here. This is 1. So I'll mark it. When x is 2, y is 4. This is x being 2, y being 4. This one is already clearly written. When x is 3, y is 7. This is x being 3. 7 is in between here. So I'm going to count 1, 2, 3, 4, 5. Because 0.2 times 5 is 1. So this is 7. When x is 4, mind you, this is 5. Between 8 and, how am I doing? Sorry. This is 7. Between 8 and 6 is 7. In the case of this one, where is the in between that we did? This is 1. So you understand why we are doing what we are doing. So when x is 4, y is 11. This is x being 4. 11 is between 10 and 12. So count the middle of 10 and 12. 1, 2, 3, 4, 5. This is 11. So we'll trace the line. This is 4 here. We trace the line to 4. 1, 2, 3, 4, 5. Please, you have to get it correct. If you not get it correct, by the time you start solving for the next questions, your answers will be far from the real answer. But if you get it correct, your answer will be very close to the real answer. When x is 5, y is 13. This is x being 5, and y being 1, 2, 3, 4, 5. This is 13. So we can trace it down there. 1, 2, 3, 4, 5. By me looking at my answer, this is when x is 5, y is 13. 1, 2, 3, 4, 5. When x is 4, y is 11. 1, 2, 3, 4, 5. When x is 3, y is 7. When x is 2, y is 4. When x is 1, y is 1. So we've already drawn the first, we've done the first thing. The next thing we are going to do is to find a straight line that will connect the whole dots that we've already listed out. But I think there is an error in my graph. You know why? I'm looking at this graph. This graph is supposed to be a straight line graph, but if you look at it here, you observe something. Notice that no line can capture this point, and this point. So, as I said earlier, I don't cut my errors so that my student will also know that errors are possible, so they can learn from it. So what do I observe? This point is off, if you look at it properly. So now I'm getting 11. That's why I noticed that when I finished solving, I was looking at it again. Look at this line. You can see that a straight line can hold all these ones till this point, but here is somehow off. So our graph is 3x minus 2, right? So our x here is 4. 3 times 12 and 3 times 4 is 12. 12 minus 2 is 10. So meaning here is supposed to be 10. I know most of us saw it from the beginning when I was still calculating for it. So the ones that saw it are genius. So let's correct it. Thank you. Thank you for those that observed it. So this is 3 times 4 is 12. 12 minus 2 is actually 10, but I want to go and write 11. So this is where the error was coming from. So let's come back to what we are doing. So you can see that the error, and I was able to know because I already know that I'm dealing with a straight line graph. I know that people that are not aware of that fact might not know. So from here, this is wrong. When x is 4, y is actually 10. This is 10. So this is where it's supposed to be. So we've corrected that error. Next thing we are going to do is draw a straight line graph that will pass through the whole point that we've done. So let's do that. So this is a straight line graph. Just put your orbital rule and make sure that you get a line that will course through the center of this point that we're making. So this is now the first question which we are asked to draw the Cartesian graph that represents 3x minus 2 under the range given, right? So this is the first question. This is the first question. The reason is not clear. Choose a suitable scale and draw the Cartesian graph for x, this, and this is a graph. So the next question we are going to look for, we are being told to look for, find the value of y when x is 3.5. So that's what you're going to do next. So we are being told to look for y when x is 3.5. All we need to go and look for where x is 3.5. This is it. Remember, for x, we are getting 0.1. So this is 1, 2, 3, 4, 5. So this is point where x is 3.5. I've been told to look for the value of y, right? All we need to do is to trace. This is 5, right? We'll trace where it meets. This is where it. If you draw this line up, let's say we'll do something like this. Let me put a dot and start going up. Dot, 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 dot. Hope I'm saying the same line. Dot, 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 dot. This is where it hits the graph. So from there, you start hitting it back. Dot, tracing where it meets the y-axis. Dot, 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 and look at where it hits. Remember what we said, that for the y-axis, each line represents 0.2, but it is meeting it in the space between, okay, I can say, look at it, 0. This is 8.2, 8.4, 8.6. So I'm getting that at x equal to 0.5, y is 8.6. For those of us that are wondering, how am I going to be sure this is correct? It's very simple. Simply use this formula to solve for it. Right? Now, mind you, because of the roughness of my work, I might not get the exact answer or the exact question answer, but my answer will be very, 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 very close. If you want to know the real answer, this is the graph. Y is equal to 3x minus 2, right? You can just say, when x is 3.5, it will be 3 times 3.5 minus 2, right? 3.5 plus times 3 times 3.5 will give you 11.5. If I'm not wrong. No, it will give you 9.5. I know 10.5. 10.5, yes. So you have 10.5 minus 2. So your answer is 8.5. So the real answer you are supposed to get, if this our graph is properly well detailed drawn, is 8.5. But we are getting 8.6, meaning we are very close. But you know the reason why we can't get it correct? Because of the slight roughness of our work. Normally it's supposed to be in between this small space here. But please, once you are close, maybe 0.1 plus or minus error, you are still getting it. The second question is, we are being told to look for y. We are told to look for the value of x when y is 5.5. So y is 5.5, x is equal to question mark. So the first thing we are going to do, we look for when y is 5.5. This is y. 5.5, that's also a tricky one. We all know that each axis in y represents 0.2. So we do 1, 2, 3, 4, 5. This is already 5, right? The next one will be 5.2. The next one will be 5.4. So this small space here, because here is 5.6. So this small space is, okay, I don't know if you are seeing it. Let me remove my hand. This is 5. If you count, this is 5. The middle of 5, 6, and 4. So the first line, as I said earlier, that we are using the 0.2 scale, is 5.2. Second one is 5.4. The next one is 5.6. So this small space in between 5.5 and 5.6 is where you're going to trace. So let's trace it. Dot, 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 dot. I know some of you might not see this thing properly, but I know you understand what I'm trying to say. So now we are going to trace it down to see where it meets x. It meets x as this small space. So we're going to trace the small space down. Dot, 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 dot. So let's get count. 1, 2, 3, 4. So it's between 2.3 to 2.4, we can call it 2.4, like it's meeting at that 2.4, close to the line. So x is what? 2.4 at y being 5.5 from our graph. So the next thing we are going to do, confirm if we are correct. How do we know if we are correct? From our equation. And solve it here. So our equation is y equal to, let me use the black pen so it's okay. Y equal to 3x minus 2. So we're being given that y is 5.5. Can just say 5.5 equal to 3x minus 2. So 2 crosses equation, it will be plus, it will be 5.5 plus 2 equals to 3x. So 7.5 is what? 3x. Right? So divide both sides by 3. X will now be, it will be 7.5 divided by 3 equals to 3x divided by 3. So by the time you do 7.5 divided by 3, what are you going to get? You're going to get 2.5. So 2.5 is equal to x. So your real answer, x is supposed to be 2.5 at point where y is 5.5. But because of our equation, the way we saw the graph, our graph is not highly accurate. So we are getting 2.4 as our answer, which is still minus 0.1 degree accurate. So the next question we are being told is, we are being told to, let me bring it down so you look at it. Look at the next question. Write down the coordinates of points where the line cuts the axis. Let me tell you what this thing means. The coordinate of point where the line cuts the axis means this is the graph of our line. Where does it cut the axis? This is the y-axis, this is the x-axis. So at the point where it cuts both the y and x-axis are what we are being told to write down. So the first thing we are going to do is, which axis are we going to consider first? So let's consider when it cuts the y-axis, and when it cuts this x-axis, sorry, the y-axis, at this point x is 0. So I'll write something like, let me use the other color. I'll write something like x is 0, y is what? Minus 2. So that's where it cuts here. The next one is where it cuts the x-axis. At this point, y is 0. I'll write it here. Y. You know, remind you, when you're writing this kind of coordinate, the first one is x, the second one is y. So I already know y is 0, so I'm putting it on the second one. The first one is what we are going to now count for. 1, 2, 3, 4, 5, 6. That's 6. Which is, remember, this is 0.6. This is 1. So x is 0.6. Are we together? So this is the third answer. The coordinate, if you have to write down the answer of the coordinate, you can just say the coordinate is 0.0, 2 and 0.6, 0. How do you confirm if this coordinate is correct? Simply come back to this equation, make y 0 and solve for x. At the same time, for this second one, make x, okay, for the first one, make x 0 and solve for y. At the second one, make y 0 and solve for x. So if you solve for it, in this case, I think we got it accurately. If you make x 0 here, if you make y 0 here, you're going to have 3x minus 2 is equal to 0. After solving for it, you're going to get this at the center. Just solve that as your own take home. So that is all for solving for the linear graph, solving questions with the graph of a linear equation. Thank you. I'm going to see you in the next class. Any confusion or problem, drop in the comment section.